Hi, welcome back, 8th grade students. This is Mr. Young here, and we're going to be looking at Unit 5, Lesson 7. And in this lesson, we're going to be using slopes to determine polygons, what shape it is. Okay? So to start out, we're going to review a square is a figure with 4 equal sides and 4 right angles. Now, I would like to focus more on the angle of it. In order for it to be right angles, you need to have perpendicular slopes. So with that, okay, what we need to find is the measurement of the slope of AB. So here's AB is going directly across, so the slope of AB is 0. Any flat line is 0. And the slope of BC, okay, vertical line, is undefined. Because, as you know, they meet at 90 degrees. They're perpendicular to each other. And from C to D is 0, okay, which is perpendicular to BC. Okay, and then also DA is undefined, okay, because it's a vertical line. And also that makes it perpendicular to the rest. So that established that we have 4 right angles. Now, typically when you have 4 right angles, it could be a rectangle, okay, also, but we're going to verify to see what about the lengths. If we have 4 equal sides, then we have a square. If we don't have 4 equal sides, then we have a rectangle. So it comes down to those 2. So in here, we can actually count this. Okay? It could be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 units. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 units. And likewise, the opposite sides are the same, so this is also 10. So when you have 4 equal sides and 4 right angles, because horizontal and vertical lines are perpendicular to each other, okay, so this polygon is a square. Okay, because it has 4 right angles and 4 equal sides. And now we're going to take a look at rectangle. At rectangle, the only requirement is that it has 4 right angles. Okay? And the 4 sides are straight, and it has 4 right angles. So we're going to go ahead and look at the slope of these items. Okay? So the slope of these items, we can go ahead and figure out EF. Okay? So let's count it. So the rise is 1, 2, 3, 4, 5, 6. Okay? So rise is 6, and the run 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay? Which can be reduced down to 3/5. Okay? Each divided by 2, and that's how we get that. And FG, so F to G. Okay? So from here to here, I have to go down 1, 2, 3, 4, 5. So it's -5, and the run is 1, 2, 3. So far you can see that the slope between EF and FG are opposite and inverse. Meaning if you take 3/5, you flip it upside down, change the sign, then you have -5/3. So therefore, we know that these 2 are perpendicular to each other. And then GH. So here's G and here's H. So from here, I have to go here to here. I have to rise 1, 2, 3, 4, 5, 6. And the run 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 6/10, and can be reduced down to 3/5. And then finally HE. So here's H and here's E. So from here, I have to go down 1, 2, 3, 4, 5. So it's -5, and run 1, 2, 3. Yep, this shows us that, again, it is perpendicular to each other. Okay? It has 4 right angles because the lines are perpendicular to each other. So, and the lengths are not all the same, so therefore it can't be a square. Okay? It's a rectangle, okay, because it has 4 right angles. Okay, so that's what makes it a rectangle. Yep. And then we have the other 2 shapes that we're going to be looking at. Trapezoid. Right? The only qualification for it to be a trapezoid is that it has opposite sides are parallel. It has one set of parallel lines. And we're going to go ahead and look at the slope of each. So the slope of HI, and going across, that slope is 0 because it's a horizontal line. And then IJ, so here's I and here's J. So down 8 and run 7. And JK, well, you can see that they're not perpendicular. Okay? So this is not a right angle up there. However, JK is 0 because it's a horizontal line, and then KH. So here's K and here's H. Have to rise 1, 2, 3, 4, 5, 6, 7, 8, and run 2. Okay? It can be reduced to 4 over 1. And you can see that we have 2 lines that have the same slope. So therefore, we can say that these 2 sides are parallel, and that's enough to say as a trapezoid. It's a trapezoid because it has 2 parallel lines. Not 4, only 2 of them are parallel. And we're going to be looking at parallelogram as well. And the difference here is that it has to have 2 pairs of opposite sides that are parallel. Right, so let's see if that's the case. So let's take a look at LM. So here's L and here's M. So we know that slope is 0. And MN, let's see, 1, 2, 3, 4, 5, 6. So down 6, so negative 6 over 2. Run 2. And then NP also is a horizontal line, so 0. So we know it's at least a trapezoid because these 2 are parallel. They have the same slope. Now we're going to see what's going on with the last slope here, PM. So I have to go 1, 2, 3, 4, 5, 6 down. So negative 6 and run 2. Yep. Each of them actually can be reduced down to negative 3 over 1. So you can see that these 2 are also parallel. So this line here are parallel, and then this line are parallel. So when 2 sets of opposite sides that are parallel, then you have a parallelogram. It's a parallelogram because it has 2 sets of opposite sides that are parallel. As you can see, that's the case. So opposite sides are parallel and equal in length, okay, but we didn't need to examine that. And then in order for it to be a trapezoid, it only needs 1 pair of parallel. So right now, your job to determine what kind of shape these items are on page 27, 28, and 29. Okay? I'm sorry, page 27 and 28. Okay. And I'm going to pick a few questions from this lesson to do with you in person over Zoom. So get your packets ready and we're going to go over it.